Right, guys, part 2 on inverse trig functions. You need your colored unit circle from yesterday's notes. We're going to use it for part of the questions, and then part of the questions we're going to do by drawing our own little triangles. All right, so this is an extra example of when you would need to draw your triangle, because it says I have a angle whose tangent is -3/4. Okay, if you remember from unit circle that we colored, tangent is here and it would be negative down in this quadrant somewhere. Okay, tangent is y over r, or opposite over adjacent, y over x, sorry, confused myself there. Opposite over adjacent, or y over x. So if we do opposite over adjacent, or y value over x value, the one that would have to be negative to put it down in that quadrant would be this one. Right, they want the cosine, so the cosine there is 4 over some hypotenuse. So we need to do Pythagorean theorem, which this is a Pythagorean triple, some of you will recognize. 16 plus 9 is 25. Square root that, and we get 5 here. And then it asked for the cosine, so the cosine would be adjacent over hypotenuse, or x over r, or 4/5. All right, so we didn't need a unit circle for that example. Now this one is asking us to use two different functions. We kind of talked about these yesterday. Pi over 3, if I go to pi over 3 right here, the sine is square root of 3 over 2. Remember, these are composition of functions, so we do them inside out. So then it's saying, where is the cosine? Square root of 3 over 2. And that is true here. The x value or cosine value is square root of 3 over 2 at pi over 6. All right, there's no 5/12 anywhere on my unit circle, so I'm back to drawing. Tangent is positive. Everything's positive in the first quadrant here. Tangent is opposite over adjacent, but I need the sine of this triangle, so I need opposite over hypotenuse. So I have to do Pythagorean theorem to find the hypotenuse here. This is 25, and 144 is 169. Square root of that is 13. So the sine is opposite over hypotenuse, or y over r. All right, so those were just a couple quick examples that you don't have. Now we're going to go to your worksheet. You were supposed to do 1 through 10 yesterday. So we are picking up with number 11. And we're going to use the colored unit circle. All right, so I put a colored unit circle on this page now. Where's the tangent square root of 3? Well, we wrote these on our unit circle yesterday, but normally you would just be looking for where, when you put the y over the x, you get square root of 3 that's positive, and that's right here at pi over 3. So that's the answer to number 11. You have to do the evens. Number 13 is, where is the sine? Negative square root of 3 over 2. The sine is the y coordinate. So that is happening way down here. Negative square root of 3 over 2. Remember, sine, we're looking in these two quadrants. So we have to answer negative pi over 3. We can't call that 5 pi over 3 because that doesn't fall in the restricted domain for inverse sine. So it was negative pi over 3. Number 15, where is the tangent 0? Okay, so tangent is y over x. So tangent is in the purple as well. Y over x, 0 over 1 would be 0, and that happens at 0 radians. So we're looking for an angle on that one, and the angle is 0 radians. Right, now we have to draw because there's no 3/5 on my unit circle. But this is a question I really like because it's asking you, when I have a triangle that has a positive cosine, inverse cosine means it's in quadrant 1 or 2. It's positive, so it has to be in quadrant 1. Cosine is x over r, or adjacent over hypotenuse, so the 3 goes here and the 5 goes here. We could do Pythagorean theorem, and it turns out that this side would be 4. But what it asks for is the secant. The secant does not undo the cosine, it flips the cosine. So the secant is hypotenuse over adjacent, or r over x. So this becomes 5 over 3. Because it's the reciprocal function, not the inverse function. Those are different, and I like that there's a question that clarifies that. All right, this is the same question, I think. It starts out the same. Cosine is adjacent over hypotenuse. It's positive, so it's in quadrant 1. But now it wants the cotangent. So we do have to do Pythagorean theorem. And 25 minus 9 is 16. Square root that, and we get 4. Cotangent, instead of opposite over adjacent, we'd have adjacent over opposite. So we'd get adjacent over opposite would be 3/4. Okay. Tangent is y over x, so cotangent is x over y, so 3 over 4. One more, and this one I think is just going to undo because it's tangent and inverse tangent. But this is asking about the angle in here who has opposite over adjacent. But then it says once you find that angle, what is its tangent? It's just 4/3. Okay, this example. All right. Number 23 is not the same function, so they're not just going to undo each other. Oops. If we are at a positive sign, inverse sign is positive in quadrant 1. So this is a reduced something, right? It was probably 1 over square root of 5, and you could write it that way, but I'm just going to do what it says, opposite over hypotenuse. And then to do tangent, I need opposite over adjacent. So I need to find this side. So x squared plus y squared equals hypotenuse squared, or x squared plus 5 equals 25. If I subtract, I get 20. X is the square root of 20, or square root of 4 times square root of 5, which is 2 square roots of 5. So now if I do the tangent of that triangle, I have to do opposite over adjacent. Okay, and there's 1 of these over 2 of these divide out, and I get 1/2 is going to be the tangent in that triangle. Okay, one more of these draw ones, I think. Tangent is positive, opposite over adjacent, cotangent. Okay, same triangle, don't need anything else, but cotangent flips it over, so I get 4/3. All right, now we're back to using our unit circle. Remember, we work inside out. So what is the secant at pi? Well, at pi, we have this ordered pair. The secant is the reciprocal of cosine. The cosine here at pi is -1, so 1 over -1 is just -1. But now we are to the outside of this, and it says, where's the sine -1? Well, the sine can't be way over here, besides which sine is the y value. We don't hit a sine of -1 until clear down here. And we can't call that 3 pi over 2. The sine is -1 at negative pi over 2. All right, number 29. says go to 3 pi over 4. When we get there, we have negative square root of 2 over 2 and positive square root of 2 over 2. So that's the point we're dealing with. It wants the cotangent, which is x over y, so we'd get negative 1. And it wants where is the tangent, negative 1. Well, I can't say the tangent is negative 1 at 3 pi over 4. It is, but that's not where inverse tangent is defined. Inverse tangent is defined down in quadrants 1 and 2, or 1 and 4, so I have to say the tangent is negative 1 down here at negative pi over 4. All right. Cosine at pi over 6 is square root of 3 over 2. And then it says, where is the cosine square root of 3 over 2? Well, we're in quadrant 1, so it's just going to be at pi over 6. These are not the same function. So where is the cosine 1/2? Happens here at pi over 3. But then it's asking, what is the sine at pi over 3? And that would be the y value of square root of 3 over 2. Right? I wish they had extra parentheses here, but it's saying if you go a negative pi over 4, so you're down in this fourth quadrant, what is the tangent at that spot? And it is indeed negative 1. And then this is undoing that, and where is the tangent? Negative 1 is indeed negative pi over 4. Here's what I was trying to explain earlier. I think I finally came up with one that'll work. What is the inverse tangent of the tangent of 3 pi over 4? All right. I don't know why I have extra parentheses there. Sorry about that. This is just an extra question. It's one where they don't cancel out. Okay. The tangent at 3 pi over 4 would be this over this, which would be negative 1. But I can't say the inverse tangent of negative 1 happens at 3 pi over 4 because it's not defined. The inverse tangent, remember, is colored unit circle purple here, and the only place where it's purple that I get a negative tangent of 1 is down here at negative pi over 4. So this is just an example of where an inverse tangent and tangent don't undo each other. All right, I was trying to make one of those up a few minutes ago and I had to delete it from the video because I messed up. All right, was that it? Okay. I want to take a minute and go into Delta Math real quick and show you what your assignment is going to be. Some of the assignment questions are on this section called Inverse Trig Visually, L6 Functions. And what you are to do is to decide, is it a vertical line, horizontal line, or diagonal line? What that means, and let me go back to my slides and write this down for you so you can refer to it later. Vertical lines are x equals lines, so they would work for cosines and secants. Okay? Horizontal lines are y equals lines, and y is your sine or your cosecant. And the tangent is y over x, which is slope. And that means we're going to need a diagonal line for tangent or cotangent. Okay? So we're going to go back to Delta Math. This one says cotangent is negative 1. Cotangent is a slope issue, so we're going to graph a diagonal line, and we need one whose slope is negative 1. Or whose y over x would be negative 1. Y over x would be negative 1, and you're going to have to think about those ordered pairs, okay? Think about this, it went left, negative pi over 2, and up pi over 2 for that spot. So that would have a x over y, actually, for cotangent of -1. And that's, then it wants to know what are the degrees and radians at that spot. So look at your unit circle if you need to, but the degrees right there are 45 and 90 is 135. And down here it's 315. This is why you should have your unit circle memorized. Here it's 3 pi over 4. And down here, that one is 7 pi over 4. We're not doing inverse functions here. It just wants the name off the unit circle. This is just practice for that. Okay, we got it right. I'm going to pick another problem. I don't want to do tangent. Well, I think I'm going to have to go into this a different way if I don't want to do that problem. All right, I'll do tangent real quick. Tangent of -1 is the same. It's a diagonal line. If it's negative, the slope is negative going this way. So we had 135 and 315 and 3 pi over 4 and 7 pi over 4. All right, I'm hoping for a new problem that gives me a different, Okay, we need to figure out where the secant would be this. Well, if we flip this over, I'm going to actually take a picture of this and do this one on a slide. Sorry. If we flip that over, the secant is the flip of cosine. So the cosine is -3 over 2 square roots of 3, which if we multiply by square root of 3 over square root of 3 would make this -3 square roots of 3 over 2 times 3. These 3's would divide out, and I get a negative square root of 3 over 2. That I can find. I need a cosine of negative square root of 3 over 2. Now, cosine is an x value, so I need a vertical line that shows where the cosine is going to be negative square root of 3 over 2, which is going to be here. X is negative square root of 3 over 2. And then you just need to tell me what those two angles are that would get you to that spot and that spot. They are 30 degrees above 180 would be 150. 30 degrees beyond 180 would be 210. It is 5 pi over 6. And down here would be 7 pi over 6. Oh. All right. Oh. Just killed a giant spider crawling up my arm. Grossed out. All right. We got that one right. I'll see if the next one happens to be a horizontal line. It's not. I don't want to do this one. Is there an example? Here's a sine one. The sine is -1. This is a weird one, guys. This is just an example, but the sine is -1. Means you need a horizontal line for -1. That would be clear down here, and the only answer would be 270 or 3 pi over 2. This is a secant, which is an x is -1, so you would need a vertical line at -1, which would be over here, and it only hits once. Cotangent 0 means the tangent is undefined, which is here. Secant is square root of 2, so that means cosine is square root of 2. Is the reciprocal of that 1 over square root of 2 or square root of 2 over 2? That's going to be a vertical line over here where it's hitting square root of 2 over 2. And then you would say 45 and 3, 45, and pi over 4 and 7, pi over 4. Okay? We're going to do some of these in our live meets as well, but I hope that helps you to do that assignment.